Good morning. Welcome everyone to this session on Cloud SQL best practices for availability. I hope all of you had a productive and fun conference and you have had a few takeaways that you can take back home and to your work and business. We have an exciting session for you, and we are hoping that by the end of the session, you will have a few more takeaways that will allow you to run your Cloud SQL instances with maximum availability. And if you're new to Cloud SQL, I'm hoping that this will get you excited to use Cloud SQL. My name is Gopal Ashok. I'm a group product manager for Cloud SQL. I'm joined by a few folks, Rahul Deshmukh, who is a Cloud SQL PM for availability. And we are super excited to have two of our valued customers, Everflow and Cape Analytics. And I just wanted to thank Jonathan Blais and Jason Erickson, who will be joining us on stage, and you'll be hearing from them in just a little bit. All right, let's get started. So today I'm going to basically kick off the session with an overview of Cloud SQL and talk about some of the exciting things that we shipped over, in the past month or so. And then Rahul will come up and talk about the availability best practices. He'll talk about the capabilities and the things that you should really care about to run your Cloud SQL instances with maximum availability. Jonathan will follow that, talk about Everflow's architecture and the best practices that they've been using. And then we'll wrap it up with Jason and Cape Analytics and Q&A. So before I get started, just a quick poll. How many of you are currently using Cloud SQL in any form? Oh. And how many of you are using Cloud SQL to run your mission-critical applications? All right. So that's quite a few folks here. So hopefully you will find the session super useful by the end of it. So let me just quickly start with a quick overview of what Cloud SQL is. Looks like most of you are using it, And if you have attended the Postgres or MySQL session, you've probably seen the pitch. But I just wanted to emphasize a few things. So when you look at Cloud SQL, it's a fully managed relational database service for Postgres, MySQL, and SQL Server. And the beauty of Cloud SQL is that it is fully compatible with MySQL and Postgres. And what that means for you, which you probably already know, is that if you're migrating your applications from self-managed MySQL or Postgres, and you want to get the benefits of a fully managed service, you can very easily do that with Cloud SQL because we are fully compatible. And when we talk about fully managed, what we are talking about is giving you something that is easy to deploy, easy to manage, and easy to operate. And one of the things that we try to do to make life easier for you running enterprise applications is to automate a lot of things and make it easy to do things like high availability, for example. And the other key thing I'm sure all of you care about quite a bit is to basically run your application in a very secure environment. So as a managed service, Cloud SQL provides a lot of built-in capabilities, security capabilities, compliance capabilities that gives you the peace of mind in terms of managing your environment. And lastly, we make it very developer-friendly. And what that means is that we provide a developer or application-centric observability capabilities using things like Query Insight, Systems Insight, et cetera. We provide support for Terraform, and we also have a very rich API that we provide, which allows you, from a developer perspective, to manage Cloud SQL as infrastructure as code, integrate with your CI/CD pipelines, et cetera. So what does this all mean? What this means is that Cloud SQL is an extremely popular service. So more than 95% of our top 100 customers actually use Cloud SQL. But what we are seeing is that customers are demanding more, and rightfully so. And what are customers asking for? What they want to do essentially is, and most likely you're also looking for the same things, is that you want to run more and more critical applications on Cloud SQL. So what does that mean? You want better performance, you want better availability, and you want better data protection. And we've been listening to that, and I'm super excited, and you've probably seen this in other sessions, but I just want to reemphasize. We have launched Cloud SQL Enterprise Plus Edition. And there are two dimensions that we are really differentiating Cloud SQL Enterprise Plus Edition compared to what we have today, which is the Enterprise Edition, and that is performance and business continuity. And quickly on the performance side, with Cloud SQL Enterprise Plus Edition, you can have 3x more performance compared to what you have today. you get better compute and memory ratios. For example, we support 1:8 memory ratio compared to 1:6.5 in Enterprise Edition. And lastly, we provide a lot of software and hardware optimizations that allows us to deliver the kind of performance that you need. And on the business continuity side, which is what Rahul is going to really deep dive into, just a couple of quick call-outs. With Enterprise Plus Edition, you get 4 nines of availability compared to 3.5 nines of SLA on Enterprise Edition. We have really worked hard to reduce planned downtime, and Rahul will be diving deep into that. And lastly, on the data protection side, we support more than up to 35 days of PITR retention. So overall, if you haven't looked at Enterprise Plus Edition, please take a look at it. It might suit some of your applications with all the innovations and capabilities that we are delivering there. So with that, I am going to hand it over to Rahul, who's going to deep dive into the availability best practices.
It's the year 2023. We have come pretty far from the days of squirrels chewing through the cables in a data center and just taking it down. However, availability is still a very critical aspect of a business. Our users are spreading around the globe, demanding 24/7 availability. In fact, availability is such a key topic that even though it's standing between you, a nice lunch, and a flight back home, so many of you decided to show up for this session. So thank you. So today, what we are going to do is talk about how you can leverage the existing Cloud SQL features and functionalities to maximize the availability that you can get for your most critical applications. Let's dive in. So how do you actually get maximum availability? You do it by minimizing the downtime. And you can think about downtime in sort of 2 different groups. There is the planned downtime and the unplanned downtime. Within the planned downtime, you can think about the planned maintenance or the planned activities which are necessary to actually keep your service safe, secure, and improve its performance and reliability. And then you have the other configuration changes which you as a user perform to make sure that your database instance actually fits the changing needs of your application. Then on the unplanned downtime side, what you have is essentially different kind of failures and how you recover from those. The failures could be scoped to within a zone, across multiple zones or within a region, or it could be something that is created because of a human error. So let's dive into how you can sort of optimize this downtime by looking at the planned downtime first and then moving on to the unplanned downtime. Taking a step back, Cloud SQL performs maintenance on your instances typically once every 3 months. The maintenance comprises of updates to your database engine, updates to the underlying operating system, and then other service changes or service updates which give you our newer features. Our goal is to minimize this downtime. That's why we pack it up and do it once every quarter. So we'll talk more about Cloud SQL's industry-leading maintenance capabilities and how you can sort of leverage those. Our maintenance experience is essentially guided by 3 different principles. The first is flexibility. Flexibility is essentially giving you the surface area that you can tweak to make sure that the maintenance essentially happens at a time that is most convenient for your application. The second one is control, which is essentially you saying that while the automatic maintenance experience is great and it works for most of my fleet, for some of my applications, I actually need even more control. And then you have the uptime, which essentially focuses on just reducing the maintenance downtime as much as possible. So starting with flexibility, Cloud SQL maintenance is fully flexible. It gives you so many different controls for you to decide exactly when and how you want the maintenance to happen. Let's go through some of those options. So the first is the maintenance window. This is an option where you get to specify the day of the week and the hour of the day so that when Cloud SQL essentially starts the quarterly maintenance rollout, it performs the maintenance on your instance when it reaches that particular week, it performs it on that day and hour of your choice. This is something that you can update as well, and Cloud SQL essentially honors the changes. The second option is actually quite interesting, and I don't think a lot of customers actually understand the value of this. This is called the order of update. You can set this value to earlier or later. Now, let's say that you have some dev test instances. What you would do is set their order of update to be earlier, and for your production instances, you would set the value to later. What that does is that both the instance with the value set to earlier gets patched a week before the one for which the value is set to later. So what you can do is, using these values, you can essentially accept the maintenance on your dev test instances first, certify it with your application, make sure that it works, and then a week later, you can accept it on your production instances. And you can thereby significantly reduce any risk that the new maintenance version may pose to your specific application. Obviously, if you're going to get maintenance on your instance, you would want to know about it. So you can sign up for maintenance notification, and you typically receive the notification either 7 days in advance if it is set to earlier, or 14 days in advance if the order of update is set to later. Now, if you have set a maintenance window, and when Cloud SQL is ready to perform that maintenance, you will see that there is a maintenance update that's going to happen. And what you can do is either accept it immediately, if that's more convenient, or you can let it happen at the time it's going to happen based on your maintenance window, or you can actually defer the maintenance because you may want to take some more time certifying the maintenance update with your lower environment, or you may have other long-running jobs running that you don't want to disrupt by taking maintenance in that way. Cloud SQL gives you ability to actually defer this maintenance by up to 28 days, and with this additional maintenance notification, you can essentially stretch this to 5 to 6 weeks of duration to make sure that you are receiving the maintenance on your production instance exactly when you want it. Now, all this is great, but let's say that you're an online retailer and you're running into October and you have Black Friday, Cyber Monday, and the holiday sort of shopping season upon you. And what the business is telling you is that for the next couple of months, we are going to be in a code freeze, and that also means that your Cloud SQL instances should not be maintained. Now, in this case, the 28-day deferral would not help. So what does? Cloud SQL gives you the ability to specify a deny maintenance period up to 1 to 90 days. So once you specify this deny maintenance period, Cloud SQL essentially says that we will not perform any maintenance on your instance until this deny period is over. As I said, Cloud SQL maintenance is extremely flexible, and we have been hard at work improving this flexibility even further. Let's take a quick look at some of the new features that we have launched in the recent months. The first one, as I already mentioned, is that the maintenance deferral is now up to 28 days, which used to be earlier 7 days. The second one is that replicas are now patched within the primary's maintenance window. What this means is, for your production instance, if you have some read replicas, all you need to do is remember to set the maintenance window for your primary instance. And when the maintenance window comes, your replicas get patched first in groups to ensure that you always have at least 2/3 of your read capacity online and ready to serve the workloads. And once all the replicas are patched, then we go and patch your primary instance. So all of this is happening within that 60-minute maintenance window, and you don't have to worry about thinking about setting maintenance windows for your read replicas. The third option is default maintenance windows. Now, it is very much possible that you do not want to actually go through all this hassle for your lower environments, or in some cases, what may also happen is that you may have a production instance and you may have just forgotten to set the maintenance window on that instance. To be safe and secure by default, we have launched default maintenance windows, where what we do is, if your instance does not have a maintenance window that you have specified, we only patch it during off-peak hours. So that's typically 10 p.m. to 6 a.m. during Monday to Friday and all weekend, which typically works well for most of the businesses. So this is how we come to our first best practice of 5, which is you should consider setting up a maintenance window with the relative order of update for your production Cloud SQL instances. All right, so we talked about flexibility, let's talk about control. So let's consider a scenario. You work in a regulated industry where your chief information security officer tells you that you need to accept and apply any recent security fixes to your instance within 30 days of their release. Let's take another scenario. You actually are running a critical application where the uptime is so important to the business that even taking 4 maintenance events in a year is not good enough, and the business would like to actually reduce that frequency further down. Or let's take a third example where you would not want to actually wait for the 3 a.m. Saturday morning maintenance window to accept the maintenance on your primary and all your replicas. You may want to get the replica maintenance out of the way first and then just let the primary maintenance happen at that off-peak hours. For all of these scenarios, the answer that we have is self-service maintenance. Self-service maintenance is something where we essentially create new maintenance versions every 30 to 60 days. And we release their information in something we call the maintenance changelog, which is publicly available. So you can go to the maintenance changelog, you can see which specific security fixes we have deployed as part of that maintenance version. And if those are relevant to you, you can actually just go and apply the maintenance by clicking on view updates and just applying the update immediately. This is also helpful in fully controlling your maintenance experience by saying that I want to perform self-service maintenance on my replicas first, then I will go do it on my primary instance. In fact, for customers who are looking to have the maximum availability and reduce the maintenance, maintenance occurrence as much as possible, what they do is they basically chain the deny maintenance period. So they take a 90-day deny maintenance, and they just sort of take another one after that, another one after that. And then within those periods, they actually go and use self-service maintenance to take this maintenance update themselves at a time of their choosing. There are a couple of caveats to keep in mind with self-service maintenance that I'll call out quickly. First one is that as soon as we release a new self-service maintenance version, we make all the older ones obsolete. So if you are actually trying to apply self-service maintenance on your primary and replicas, you want to do it in a way that they're all patched to the same maintenance version around the same time. The other thing to keep in mind is that while you can change your deny maintenance period, at the end of the day, you should always consider being safe and taking a maintenance on your instances to make sure that they're getting the security patches that they need. So this is our second best practice, which is to use self-service maintenance if the default maintenance controls that you get with Cloud SQL are not enough for some of your instances. Moving on. So we talked about flexibility and control. Now we come upon uptime. So it's great that Cloud SQL provides you all of these options to perform maintenance. You can take it on a weekend, you can sort of defer it, you can deny it, you can do all of that, but it's still a downtime. It's still a disruption. What if there was a way to actually reduce the downtime so much that at one point, the maintenance event itself essentially becomes uneventful, unremarkable, and just simply boring? So that's exactly what we are trying to do here by reducing the maintenance downtime significantly. And we have done that with Cloud SQL Enterprise Plus, where the maintenance downtime is now less than 10 seconds. Now, just to set some context, for Cloud SQL Enterprise Edition, we already offer a pretty low planned maintenance downtime of less than 30 seconds for Postgres, less than 60 seconds for MySQL, and less than 120 seconds for SQL Server. But with Enterprise Plus, both MySQL and Postgres now have the maintenance downtime of less than 10 seconds. Instead of detaching the underlying storage from the primary instance and attaching it to a cold VM and starting that up and taking that longer downtime, under the hood, we are essentially performing a rolling upgrade, which makes this process significantly better and reduces the downtime quite a bit, and while still maintaining your IP address and all your instance configurations. And we have seen fantastic customer feedback on this. You can see a quote from one of our customers who saw over an 80% reduction in planned downtime when they tested Cloud SQL Enterprise Plus. If you're interested in looking at how this feature actually works in action, I would encourage you to check out the MySQL and Postgres sessions because they did a demo on this very feature. So that brings us to our third best practice, which is that if you want to run your instances with the highest availability possible, consider running those on Cloud SQL Enterprise Plus. Again, this may not be the requirement for your entire fleet. You may have even some production instances where you do not actually need such low downtime, but for the ones that you really do, Enterprise Plus is a fantastic choice. So we talked a lot about the planned downtime. And again, you can sort of configure it, you can move it from here to there. But now we come upon the unplanned downtime. Now, no one, and I mean no one, likes that 2 a.m. page, which just results in anxiety and frustration and stress. But then how do you actually plan that is something by definition unplanned? Let's see how. So when you're thinking about planning for the unplanned downtime, you want to first start by defining your RTO and RPO goals. Now, just as a refresher, RTO is your recovery time objective, which basically tells you the amount of downtime your application can accept. RPO, on the other hand, is the maximum amount of data loss, which is also measured in time that your application can accept. Once you define your business continuity needs based on the RTO and RPO, then it becomes a question of optimizing that business continuity and how much price you're willing to pay for it. So with this framework in mind, where if you want higher business continuity, it typically comes with redundant hardware, which results in a higher price. And so you want to make sure that you are optimizing and understanding all your options and making your choices based on what you want to, what is more important for you. So with this framework in mind, let's actually talk about, the different categories of the unplanned downtime and how Cloud SQL helps you there. So we talked about zonal failure, which is essentially a failure scope to a zone. Now this could be your database service, the database engine going down, your VM having a failure, underlying disk having a failure, or the rack or the zone itself just going down. For these, Cloud SQL makes it very easy for you to protect your instance using our high availability feature. So when you have a high availability, when you enable a high availability feature on your instance, what we essentially do is we create a standby instance in a different zone, which in this case is zone B. And then we create an underlying regional persistent disk, which does synchronous zero data loss storage replication across these zones. We also end up deploying a load balancer endpoint so that your instance's IP address remains the same throughout your failover and failback. And your application doesn't have to worry about this change happening, which typically takes about 60 seconds. So if zone A goes down, Cloud SQL detects that zone A is unavailable, and it fails over the instance to zone B in less than 60 seconds. And after that interruption, your application essentially reconnects to the same IP, and it can resume. So this is our fourth best practice, which is that for highest availability in case of a zonal failure, you definitely want to make sure that you're configuring your instance with HA, which is our high availability configuration. Okay, let's talk about regional failure. So regional failure is anything where essentially it could either be multiple zones having an issue, or it could be a network issue that spans across different zones or a whole region, or it could be some sort of a natural disaster phenomenon happening that just spans a large geographic area. For this, what you cannot do is rely on resources deployed within the same region. So you have to think multi-region. For that, how does Cloud SQL help? What Cloud SQL offers you is the concept of a cross-region read replica. For a Cloud SQL primary instance, you can create a read replica in multiple different regions. Now, let's say that you create this cross-region read replica, and in case of the failure of region 1, you promote this replica, you make it a primary instance. But now that it's a primary instance, our earlier best practice said that you should enable HA on this instance. But that's going to actually result in some additional downtime. So how do you avoid that downtime and optimize your RTO? You can do that by configuring the replica itself as an HA replica. So we offer the option for you to configure your read replica as a highly available read replica. Now let's also say that in your primary region, you're running some critical read workloads that you're offloading to a regional read replica. After the region has gone down, your secondary region is up, you're essentially promoting that cross-region replica. It has become a primary, but now you need to also offload the same read workload within this region. You can always go and create a new read replica in that case, but what Cloud SQL also allows you to do is create what we call as a cascading read replica. So this is similar to any other read replica. The only difference is that its primary is another replica itself. So in this case, when you promote that cross-region read replica, not only do you have an instance up and running in a different region, you also have HA enabled on it, and you also have its own same regional read replica that you can start offloading the read workloads to. So that's our fifth best practice, which is that for highest availability during a regional failure, you should consider configuring a cross-regional read replica with high availability. Now, we did say in the session title that there are going to be 5 best practices, but seeing as all of you are here, I'm going to throw in a 6th one. So let's talk about the user error. So let's say that user performs some incorrect data definition or data modification query on the database, or performs the app has a bug and it performs some incorrect changes to the database, and you need to actually recover from those. To do that, Cloud SQL offers you multiple different options. We have different types of backups. They are called automated backups and on-demand backups. Automated backup is something that Cloud SQL performs on your instance once a day, and you can define a retention period for this backup between 1 and 365 days. On-demand backup, on the other hand, is something that you perform yourself, and it doesn't have an expiration period. Cloud SQL also allows you to perform point-in-time recovery on your instance by storing the logs for your instance. This feature is available along with the backup features across all 3 of our engines. So as you can see here, you can essentially specify a date and point in time, and you can recover back to it. Now, point in time is so critical for a production database that we have invested significantly in it over the last few months. Let's take a look at some of our recent launches. The first one is that, as Gopal mentioned, Cloud SQL Enterprise Plus offers you 35 days of point-in-time recovery, which is a 5 times higher retention period than what you get with the Enterprise Edition. Now, this additional retention actually does not come at an additional cost to you, because Cloud SQL now supports storing your logs to Google Cloud Storage bucket for MySQL as well as PostgreSQL. We launched this for PostgreSQL a while ago. It's now also available for MySQL. Now, this is great, but what if your instance is actually down? For your PostgreSQL instances, if your instance is down, you can now perform point-in-time recovery with a recovery point objective of 5 minutes or fewer, because we typically store the log backups to the GCS bucket every 5 minutes. But what if the zone in which your instance was running and that you're trying to perform this point-in-time recovery to is also unavailable? Now, for Cloud SQL, point-in-time recovery for offline PostgreSQL instances can also be done to a different zone within the same region. This gives you one other great way to to protect your instance from any zonal failure with that 5-minute RPO. So that brings us to our sixth and last best practice, which is you should always enable automated daily backups and point-in-time recovery with a retention period of that fits your needs and save your instance from user errors and other catastrophic events. So I talked about a bunch of different things. It's great, I'm a PM, that's my job. But what would be more interesting is to actually hear from customers like yourself who are using these features and who are maximizing their availability. So let's do that. So let's welcome Jonathan.
Thank you. Hi. So it's a pleasure to be on stage. So my name is Jonathan Blais. I'm the co-founder and CTO of Everflow Technology. So we've been using GCP for quite a while. So we've been through the journey. So I'll try to bring some colors to what Rahul and Gopal said. So founded in 2016. So we're a partner marketing platform. So we help brands and agencies track their marketing campaigns. So we've been using GCP, like I said, since day one. We leverage multiple products such as BigQuery, Bigtable, PubSub, but also Cloud SQL, and most precisely MySQL, which is the backbone of the environment. So like I said, we've been through the journey. So I want to just spend a few minutes with you to kind of tell you what we did, what went well, what did not go well also, because I think this is important for you guys in the room to understand that. So when they first asked me to join this session, I asked myself, why should I do that? I mean, we're just I'm the CTO of a small startup. There's a bunch of people in the room. Well, we all have different strategies, different use cases, different budget too. But we all have one common goal. No one wants to get a pager at 1 a.m. on a Sunday morning because your app is not able to connect to the database. So we all want the best availability. So I'll try to express that with what we did. So the first one is, as you see, as Rahul mentioned, we leverage the zones quite a bit. So we have our master, our failover, and a bunch of read replicas in different zones. We never want to have everything in the same zone, because if the zone goes down, well, at the same time, your app is going to go down. So that's one thing we do. Also, I mentioned the standby, sorry. So the other thing that is important for us, is the maintenance. And this is quite a hot topic at Everflow. I know there's a bunch of improvements that are coming, but I'll be very transparent with you. Anytime we get an email about an upcoming maintenance on a master instance, this is never something we enjoy, because we know that in our case, that's multiple minutes of downtime. So we're using 5.7. So this is something that has been going on for a while, and we did a POC with Enterprise Plus. So that went from multiple minutes to seconds. So this is a true use case. This is not an infomercial. This is us trying this feature, and it worked really well. So as Rahul also mentioned, there's a bunch of controls. So you should take the time to look at these controls and make sure you use them to minimize your downtime. And couple that with Enterprise Plus, I think you'll be in a good spot. So the other aspect is disaster recovery. As you can see there, we do use multiple regions. So we have a read replica in a different region, and we do that for all our different shards. The reality is you need to look at the activity on your master, because one thing we notice is if your master is super busy with writes, what could happen is you'll see a replica, a lag on the replica in the other region. So this is something you need to carefully look at. Always ensure that your master is in a good state and you're not just writing like crazy, because you're going to see an impact on the cross-regional read replica. Yeah. Sorry. I'm not doing that every day, I can tell you that. Whoop. All right, sorry about that. Another thing we do is we run manual backups. Yes, the log retention is going to 35 days. That's awesome, right? But one thing we do is we run our own backup that we export to GCS. with multi-region, because you never know, right? If you need to look at something from 60 days ago, a user did something, like there's an audit, so that's something we do. And if you do something like that, make sure you test the integrity of your backup, because you could be taking backups for months and years. If you never test them, they might just be faulty. So something that you should consider. Now let's just focus a bit on the diagram. So one thing we do is we're deployed on GKE. So we're using like a microservices environment. So everything we do is through GKE. And like top left, that's a pod, right? So you have your app, Cloud SQL proxy, HA proxy. So what's important for us is like we don't want to have, like let's say a read replica goes down. We don't want to have to manually, like change the config and all that. So all pods are using HA proxy with all the read replicas. So if one goes down, automatically it's going to be, all the read requests will be routed to the appropriate read replicas. And if it comes back up, automatically it's going to be added back to the pool. So that's something you should consider if you're using multiple read replicas. I'm not saying you're using GKE, but like you need to have this layer between your app and Cloud SQL for like HA. The other thing I want to point out is like this is like the current state of our infrastructure. While in 2016 it was much simpler, right? Like one master, one read replica, and we started to like add more customers and to scale. So what we were doing is like changing the specs of the machine, make it bigger and bigger and bigger. At some point, we kind of hit the limit and we had to shard. So that's what you see, like we have like multiple shards. And the way we scale horizontally is much like now we have the control. It's much more seamless than trying to just change like and make the machine bigger and bigger. So something like, depending on your app and your use case, you should consider like also sharding. More machine, more money, I get it, but at some point if you need to scale, that's one way that worked for us. Another aspect is when you set up your cluster, always think about like having n+1 read replicas. If your workload is like super tight based on your current read replicas, if one goes down, you want to be able to absorb this workload. Again, more money, I get it, but you need to have that. For like a mission critical app, you need to think about these things. Another aspect I would recommend is like when you start using Cloud SQL, it's managed, all right, it's beautiful, but like make sure you understand like the underlying, like the metrics, how it works, because as you're going to be scaling, you want to make sure that you're able to act on it. So if you don't know, like if you just think this is a manage, everything's going to happen magically, it's not. Make sure you get control on that instance. Yeah. One last aspect on the application. So this is, again, very specific to us. What we're trying to do is anything that could be done asynchronously, like we try to do it. So we have like our API, like this one, okay, all right, sometimes it needs to write to the master. So if we're down for multiple minutes, we're down. But everything we can do asynchronously, we use a pub sub a lot. So you should try to decouple like your different services so that everything that runs in the back end, if your master is down, well, at least you can pause that part. So you're not going to be like spinning your wheels and like trying to talk to your master while it's down. So you can decouple your environment like that. Again, that's very much so like related to us, but something you should consider. Because like when you're running at scales with that many schemas and tables, downtime are taking longer. So something to consider. So quick final word, sorry, it went fast, but like for us, like the E+ and Cloud SQL 8.0 is going to be a game changer for us because like the downtime is going to be like much more minimal. And I'm not sure if you saw that, but there's also the data cache in terms of performance. We noticed like 3 to 12x improvement. So it's going to be very interesting. And yeah, looking forward to it.
Thank you, Jonathan. Really great to see all the things that you're using with Cloud SQL, and really great to hear about all the benefits you're getting from Enterprise Plus. Now we'd like to welcome Jason onto stage for a quick conversation about what Cape Analytics is doing with Cloud SQL.
Great. Happy to meet everybody here. Fantastic to see so many people interested in databases. A surprise to see that, but excited nonetheless. So I'm Jason Erickson, VP of Platform at Cape Analytics. At Cape, we have built machine learning models that are able to process aerial and satellite imagery and generate accurate, objective characteristics about those properties. And we work with our insurance partners to provide them the information that they need to accurately understand the risk about each property that they're planning on insuring. We were founded in 2015. We've been a Postgres company from the very beginning, both for its enterprise support, but most specifically because it has rich geospatial features. At Cape, we deal with real-world objects, so being able to store and query parcel outlines and building outlines directly in the database is incredibly important to us. We're actually also a recent convert to GCP, having migrated in May of 2023, and we're very happy so far. And today we serve over 1.5 billion spatial objects through Cloud SQL and Postgres with sub-second latencies for our clients.
That's awesome to hear, and welcome to Google Cloud.
Thank you.
All right. So let's talk a little bit more. Rahul, do you want to?
Yeah. So one of the, I think, interesting things that I think everyone in the room would want to know more about is your migration. So I think you mentioned that you sort of migrated over from AWS Aurora to Cloud SQL. Could you talk a little bit more about that and how that experience has been and what best practices sort of you learned?
Yeah, absolutely. So we migrated our entire infrastructure over from AWS to GCP. We set ambitious goals for ourselves. We aimed to complete the migration in less than 4 months and with 0 downtime for our clients. So we had a lot of non-starts, but a lot of things, learnings that allowed us to complete it successfully. So first, take time for data transfer. We have over 30 terabytes of information that we needed to copy. And we used a combination of Google's database migration service as well as PG dump and PG restore to move that data over. Regardless, it still takes time to move that much data, so plan for that. The second thing, make sure you test against production equivalent workloads. The same instance type on a different service might not perform the same. So when we loaded our data into Cloud SQL, we tested very thoroughly, and we were able to identify issues using query insights and tune our instances. And we're actually faster on Cloud SQL than we were on Aurora. And then finally, the last but most important thing, have a fantastic team. It was a group effort by all the engineering team at Cape Analytics with also support from Google. And that's the reason why we're able to get this done so quickly with no downtime for our clients.
That's awesome to hear. The amount of time that you took to just migrate over seems that looks like a great experience. So I'm pretty sure then availability and disaster recovery, all these are super important for you. So what are some of the principles and approaches that you took when it came to availability and disaster recovery?
Yeah. So I mean, we sell data to insurance companies who are, by definition, some of the most risk-aware companies in the world. It's in their DNA. So from the very beginning, they had very strict DR and availability requirements for us. The first principle is leverage the built-in tools that are available to you. On the cloud, and especially GCP, we just saw a tremendous amount of work by a lot of people that enable companies like us to turn on high availability with the click of a button, enable backups, another click, even set up cross-region replicas very easily. So don't reinvent the wheel. Use what's available to you, save time. And then the second thing, design your backups and disaster recovery for your services. We have one database that we need to back up via a read replica because we have a very tight recovery point objective. But a lot of our other databases that we control, primarily our geospatial ones, we can hit our objectives simply through a multi-region backup and then restore into another region if necessary.
Awesome. All right, so thank you both for being here. Please give it up for Jason and Jonathan for being here.